to start the morning, y'all. This is RO number 55. We're jumping way ahead. Reason we're jumping way ahead is I called ROs number 48, 49, 50, 51, 52, 53, and 54. I got 3 or 4 disconnected numbers out of that deal. A couple of the amps I don't think ever got sent up, and nobody wants to answer their phone this morning. So instead of sitting here idle, twiddle my thumbs like there's a lack of projects around here for me to work on, I'm going to jump onto RO 55 and see if I can get ahead. Pretty sure this guy's going to call me back. He's called me a couple times. So he's been waiting. It's time to get started. So in his notes, which are concern, it's literally like one sentence, was working fine and watts started to drop off. It's the output tuning capacitor. It's always the output tuning capacitor. It's always the output tuning capacitor. Well, Mr. T, what we're going to do for you this morning is we're going to strip this baby down. We're going to make sure she's clean on the inside. You have some severely stripped out holes in your heatsink. We're going to repair that with some crush nuts. We're going to fix your output tuning cap so it quits arcing and your power won't be dropping off anymore. We'll squeak the extra little 100 and some watts out of this that we can get depending on what transistors are in it. And we're going to make it ready to come home after we put some new power wire on it and get rid of this garbage. Because it is garbage. Garbage, I say. Garbage. This is a pretty decent example of what this amplifier was when it was young. It's in pretty good shape. It's got 8 Toshibas in it. They're getting driven by 8 454s. 455s, pardon me. Alright, so we're going to do a thing called soft key. First, let's check this. Okay, preamp is working. So we're going to do a thing called soft key, where I just key it up and I see what's actually happening. Let's boot up our FLIR. Our forward-looking infrared. This is a fancy-ass thermometer gauge. So this is a thermal imaging camera pickup, and then how we actually achieve our temperature is with that infrared thermometer. It's the same thing that you'd buy at like Harbor Freight for like $19. So you can cook steak on your grill, I guess. That's where we get the image is what we're after. So first off, we got the amp in the off position. We're gonna make sure we're up in the high. We are, everything's off. Hello, 1, 2. The other thing that these things were notorious for is this relay going bad. Notorious for it. All right, so we're putting a water 2 in it. And we're building power. Hello, oh yeah, we're down. Hello. Hello. All the pills are lighting up. We'll heat in this output resistor here. Hello, 1, 2. Let's turn you up on your side. Hello, 1, 2, 1, 2, 1, 2. Cap's getting hot. Hello, 1, 2. There's our bitch right here. This cap. That cap is hotter than, so's that one and that one. These caps, and we're missing one here. No, we're not, it's there. These caps on the output transformers. Second biggest thing to go bad. The Arco that they used to put here was the #1 failure. The second biggest failure are these output tuning caps. And then the third failure is, of course, the input attenuator. And then the fourth biggest problem is that everybody's got to get in here like this. These have all been adjusted. Everybody's got to get in here and adjust this to think they're going to get 5 more watts out of it. So this cap's getting really hot. So I think we're going to be playing the chase the cap game. I'm going to pop all of these off. We're going to measure all of these caps, and we're going to see where we sit, because one of them is definitely broke down. Something in this department, because we're seeing an imbalance here, which is showing up as heat here, but then this output cap is also getting hot, but this is cold. So rather be than safe than sorry, we'll just go ahead and pop all these up. Let's give them a quick check. Okay, so all the input caps check out. The output caps are not too far out of spec. This cap is a little low, but the other thing is the inductor's been bypassed. This thing's been burned up a few times, and I think it's been repilled. The solder work in here is questionable around the transistors. Some of this stuff, like there's traces that have been just flat, like right here, ripped off on the inside of the amp. Let's get in here so you guys can enjoy it too. It's like here, that trace has been ripped off, and we go over here to the output side. This one's been ripped off. But what really caught my attention was this. If you notice this output transformer, this side is normal colored and this is burnt black. And when we flip the amplifier around, it gets even better. This tells me that this tube is not making good contact through here. So we're going to take that whole transformer out and figure out what's going on there. This is also, this trace here on the back has been ripped out. And this is all burned off. So this thing's been on fire a couple times. It's no big deal. It happens. So there should be an inductor that's like this one, but over here. I've had a few that ran better when we got the inductor removed, but this thing's been worked on heavily. There's the remnants of a fire also here. And a pretty good remnants of a fire here, and you can see where soldering iron has been making contact with that piece of RG, was it 172, 17, whatever it is. This is the solid steel center conductor. This isn't the RG400. So we're going to pull all these caps off. We're going to replace them with metal clads, all the output caps, so we can forego having the problem of this breaking down in the future. This is, well, 1200 picofarads worth of capacitance on each one of these. It's just three 330s all stacked together. So, 6, 9, 12, and then plus the additional 90. So, yeah. So 6, 7, 8, 9, 1100 if-ish. Probably get away with putting thousands over there, but yeah, so 9 and 990. We'll put thousands over the outputs of this, and we'll be done with it. This transformer getting hot and burning up is a bad thing. So we're going to rip that transformer out. We'll take all the windings out of it, and we'll reflow the solder on it, and then we'll put this all back together and give it a bath and put some wire in it, and we'll give it a test. Pretty sure most of our problem is right here. Okay, so it's been a couple days since I filmed the last couple segments. There's a lot of stuff going on in my life behind the scenes right now. I've been very busy, but I got a couple free minutes. I got to get this finished and off my workbench. I told the customer I'd get to this, so I need to get this buttoned up and out of here. I think where we left off, we were talking about this output transformer and how it was all burnt and discolored and having problems. So we went ahead and we pulled the transformer off, and this is what the board looks like underneath it. That is some serious heating. That's not corrosion or oxidization, that's from heat. Now, let me show you the output transformer. This is the back side of it. This is the bottom of it, and here is the front of it. Here's our side view. Look at how hot that's gotten. This is our other rear view. Okay. Now to get that transformer out, I had to remove this piece of coax, and that's how we've been looking at it. Well, first off, this is the part that goes to the combiner, this tip. It wasn't soldered in. When I unsoldered this end piece here, well, first I unsoldered this and then this, and then I lifted the coax up, and then unsoldered this, it fell off. But then we have another small problem. You see that cut mark right there? That cut mark and the back of this transformer line up with each other just like this. They touch right about like so. See that? This burn through arc mark is where it's been making contact on the edge of this transformer and shorting out. This tube is just where it, around the edge of this tube here on the input, you can see there's no solder contact here whatsoever. This is where I unsoldered it, and this is where I pulled the capacitors off. So the whole front of this transformer looked like this portion of the tube until I unsoldered it. This I have never seen before. So now that we've all documented it, let's give it a little bend. You know, if this was anything other than M17 mil standard coax, this would have probably caught on fire and cost you all the transistors. But I can see how if this thing was getting hot, and you know, me moving it around and stuff when I went to take it apart, I mean, looking at it might have been enough to cause it to not be connected anymore. Take this jacket off. Oh, this thing's been hot as hell. So well, it burned enough that it left. I don't know if this little stippling pattern is going to show up on camera, but see, it all should look like nice and clean, like the bottom half of this thing. Look at that. This has been hot. If this wouldn't have been Teflon dielectric, the whole box would have burnt to the ground. I mean, that's crazy. That's where it was arcing out, by the way. Okay, let's put all this aside. Hopefully we'll be able to salvage this transformer. I'm going to wash this with some rubbing alcohol, get all the corrosion and oxidization out of it. Then I'm going to come back and etch it with probably some uric acid and then dilute that with some water. And hopefully we can get this to take some solder for us here. It's been hot. And oh man, you know, as hot as this has gotten, no, it shouldn't affect the ferrite material that much. I was thinking magnets there for a second. If you get magnets really hot, they'll lose their magnet charge, their field flux, because it allows the magnet to realign itself. I think we're going to be okay. Let me get all of this cleaned up, and we'll get this put back together. I just had something else pop in my mind I got to deal with here in a minute. Okay, so I don't know how well this is going to translate to y'all, but this is about as close a picture as I can get with it being in focus still. There is a trace that is supposed to come up and go across and attach here. You see this little dark fold? That's what's left of this trace that's folded over. So the rest of the trace is atomized. It's kind of folded up here on the side. You can see me kind of flicking it with the... Okay. This little relay is part of the biasing circuit. And that's got to get fixed. Then over here, now that I've given this a bath, down here, we've got a hole blown in the board down here in this back corner underneath this resistor. That just looked like corrosion and oxidization in it. This has come apart in a wicked wild fashion right here. And then again over here, underneath this resistor, we have the exact same thing has taken place. This thing has been wildly on fire at some point or another. This resistor here has been replaced at some point. We can tell by the burn mark on the copper that surrounds it. I washed this whole thing, by the way. If you notice, this resistor, and this resistor are all the same style, make, and color band. But then we go over here, like so. This is the wrong value, though. Now we've got the stock values. So I would bet that at some point or another, this piece of coax shorting out has burned up the back half of this box. And whoever did the pill change wasn't quite as thorough and they didn't catch the coax being burnt, on top of the tuning capacitor being not right. I would bet. We were able to get the... So basically what this is you got a little piece of copper that's mounted to a piece of fiberglass, and that makes the phenolic structure. The copper is still intact. We were able to get this to resolder to the tube, and we were able to get the ass end to resolder to the tube on both sides. So the phenolic is discolored, but it doesn't change the operation of the transformer. It being unsoldered and not having a good connection changes how the transformer operates, but all in all, this, I mean, it isn't mint, as in like perfect, the discolorization of the fiberglass, but it doesn't change its insulation value. I'd be very concerned if the burn continued down to the bottom, because then we have a conductivity issue that we have to worry about. These two tubes on the back are shorted together. The burn that's taking place here in the front, you'll see that it basically stops about middle of the phenolic. Let me zoom in here where you guys can see this a little bit better. It stops in the middle of the phenolic, so I don't have to worry about these two pieces of ferrite in the front conducting to each other. What we do have to worry about is this little bit of, is it burn? No, it's flux from the resolder. So is that. There we go. We still got good structure in the front. If this was burned up in here, if this piece of phenolic was burned and burned all the way through on both sides here, then we would have to worry about this conducting RF, and then we'd have a shorting issue. But the front of this transformer looks a little rough, but where it counts it's fine, so we're going to reuse this. I don't have a replacement to put in here, but I mean, I guess if I had to, I'd recut a new plate for the face with the Dremel, but I think this is going to be okay. Now that we found the thing that was causing it to catch on fire, yeah, I still want to do metal clads all the way across here. They have a tendency to last longer because these are notoriously famous for giving a shit. So, and they might test good, like on the tester out of the amplifier, all the way cooled down. They could be failing underneath temperature, right? So the amp gets up, we'll say 130 degrees, heat soaked. You know what I'm saying? It's just not worth the risk. It's not worth the risk of this thing coming back and the guy having a problem. So, repair trace. I got to clean this up because there is some loose copper that's floating around down here. So I'm going to end up taking this. Oh, here. Hold on. Hold on. I'll just do it with you guys here on a camera. So, let's see here. I'll lift that up. I'll lift that up. I want to reattach this copper that's got the hole in it. The reason I say I got to do that is, let's say that for some reason, let's just say there might be vibration or something in this amplifier's future, that this shorting over to here would cause this whole section to go dead, which then in turn would cause an imbalance because we can't see into the amplifier. And in these smaller amplifiers like this, most people don't use meters. If we have the potential for an electrical short through here, see, this is just all just folding up, and the distance between the ground and the combiner is just the thickness of the tip of this pick. So I need to clean this up, secure this down so it can't move and we don't have the potential for a short in the future. I need to do the same thing over here. I have to lift this up and evaluate what's going on with this refried mess that's underneath here too. But we're going to get that all buttoned up. We're going to get the capacitors put on the transformers. We'll cut ourselves out a new piece of RG400 and we'll route it so it's not super duper close to the edge of the transformer here. We're going to route it a little bit different. We'll probably bring it up and over. So, okay, got that covered. Now I have to go deal with some other stuff. So as you guys know, my wristband, because I got to go back to the hospital here in about an hour. I've been dealing with a lot of personal things, not my personal health, but one of my close family members. Everybody on Patreon knows what's going on, but I was sitting up in the hospital last night at a doctor's consult from my family member, and my mind was just kind of drifting a little bit, and I went, I know I've got at home about 15 dozen scrap amplifiers. So I buy amps from time to time just to get the transistors out of them and then keep them around for parts. This is an old Power Plus, right? In the day, there was a limited different set of companies that you could commercially openly buy RF transformers from, right? And these are just nothing but off-the-shelf commercial transformers. So I don't like the look of this transformer, and I don't care how much solder I put on it. I would not feel right about doing this repair without being able to replace that transformer. We could probably get away with it, but that's not our goal. People send things here to actually get fixed, and if something is burnt, they expect me to replace it and repair it properly, right? So I thought, my God, I got to have somewhere in that massive stack of parts an amp that's got the same exact transformers in it. Same exact transformer. I'm going to pull this out. I'll probably pull this end one out. I bought this just for the transistors that are in it. I mean, come on, at 102879s. Why wouldn't you? The rest of this thing is junk to me, right? So like the heat sink, I'll pull off. I might reuse on a future project. Probably not. It'll sit here with the other giant piles of heat sink I've got. Or knowing me, I'll probably take this transformer off, put the lid on it, and not think about it again for another 5 years. But I went quick looking, and I went, oh, look here, this is exactly what I need. It's got the exact same cores. And before we can say that they're the same, we're going to do a unihenry test. That's where we take and we wrap. We'll say that we'll wrap this transformer with 2 wraps of wire, and then we measure it. Then we take the exact same piece of wire out of this transformer, and we put it into this transformer, and we test it with the unihenry meter. If they are within 1 or 2% of each other, that means the material make and how the transformer affects the wire is the same. So then I can take this and go, this could be type 61. This could be type 43. I'm assuming it would be 61 since they're primarily the best to use for your output transformer for our frequency is type 61. So let's pull this up. I'm going to get it cleaned up. We'll put a couple wraps in here because we know we got good conductivity. We're going to check the unihenry on it, pull the wire off, we'll stick it through this, we're going to measure that, and if they're the same, we're going to put this in here and we can move on, and I don't have to worry about this. I can sleep softly at night, and I can send this back with the amplifier for the guy to hang on his wall of shame. Boom. Diggity. So, put a couple windings in this. We've got 2 on the back, 3 on the front, okay? So I like to think of things when I count them from the front. It's got 3 turns. I did that to get the unihenry number up. And this has got a 7.4. All right. Now what we do, and if it's within a unihenry, so if I see a 6 or like a 5.9, we're safe. Okay, we're in the safe butter zone. If you really want to build a real competition amp, like you're really wanting to get every last eeba-jeeba little watt out of everything, you would take this same process. This is one of about 30 different things that you do on a comp box that we don't show on video or talk about too often loud. We'll take probably, let's say like an 8-pill, you need 4 transformers. Well, we'll take 20 transformers and measure them all out, and we'll get every transformer so the unihenry is exactly the same. We can't have a huge deviation. We can have a little bit, not a lot. So let me get this other wire pulled up and be able to get this last test in, and then we can go ahead and solder this part in if it works. There we go. So, let's see, where are we at here? 6. These are basically the same material, same make. This is going to be a little different because obviously this thing has been hot and it's going to change the magnetic field a little bit. Now if I was to use, let's say this was type 61 and then we had one that was made out of type 43, we would see this number be drastically different. It'd be like 5 to 10 unihenries difference. So this will work for that. It's been a couple days since I was out here working last. I've been up the hospital at this point quite a bit. I thought, well, I'll come out here, I'm going to run this thing, and we're going to go see what this thing does. Well, I keyed it, we keyed, and then I modulated, and then I proceeded to see sparks come shooting out from in this area of the board. And then this trace over here decided to let the smoke out. Well, this trace is the on-off. This goes from the on-off switch, comes up through here, over through here, and gets picked up down here. Runs up, runs all the way across, comes down, comes out, and goes to our burned up trace over here on our bias relay. The trace here, which runs over here to the bias circuit, is getting incredibly hot, like instantly hot. And that can only be a couple things. Yeah, it's making power. It was making like 600-700 watts, no problem. Just drove right up there. The problem is the trace let go. That trace goes back over to the on-off switch. Now, we'll make it so that this thing just kind of makes contact over here for the hot. As you can see, we still got on-off indicator. So why'd this trace go up in smoke? It shouldn't. This trace literally dumps out and it comes right down here to this burned up son of a bitch, and then it goes, the next little component that we got is the diode that protects the key-in circuit. This isn't adding up. Let's see here, let me show you. So this trace that is burned up and has been scorched up before, this thing here, I'm sure my positive is disconnected, it is. This trace here let all the smoke out. But as we can clearly see, we trace this trace along and then it dips down. Well, it dips down, it dumps out here. Well, this trace runs over, and I don't know if you guys remember this repair that we did on this trace over here. It in turn is a 12 volt hot for the bias, and then the bias 12 volt, this trace here is getting screaming hot. So that tells me that there might be something going on underneath the board. Well, to pull the board off, we've got to undo all 4 of the screws, these 2 here, the 2 in the back. Then I got to undo all the transistor screws, and then I can lift this thing up and we can see what's going on underneath. Which, unfortunately, I think that's what I got to do. I have to eliminate that short point. Then I got to come back and repair this trace over here. Then, I mean, that's if we can find a short in this department. But our load is definitely, a resistive load, whatever's going to ground is over here. It's not much. We've got these 2 resistors, this resistor. This 75 ohm resistor, 10% 5 watt, is what runs the bias for here. Comes through this trace, and then off of this trace here is our diode, which represents our load to ground, our actual coupling to ground. And then off of these 2 5 watters, or pardon me, 25 ohmers, we have a diode that's here. I'll just simply taking a voltmeter and go bleep bleep. We're going to see ground anyhow because we've got all these 10 ohmers in line, but they're all tied together in series. So we've got a 10 ohm, 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 8 10 ohms. So like what? We've got less than a quarter of an ohm, if that, worth of resistance going to ground. This is going to go beep, show us that we have a short. We don't really. Like I was saying before the camera died, this is going to show that we have a ground short. But we don't really, because it's hidden behind the resistors. We have to have a hard coupling to ground. So either something is shorted out here, which this is new, because we ran the box and showed that it was working, and we didn't have this resistor issue, but this trace was disintegrated. So this issue has been ongoing. This back here also showed very much burnt damage, but now that we've repaired this, now we got to switch 12 volt hot. We've got to be very careful because this is a direct pipeline to the input network, and this will pop our pills so fast. If we have 12 volts dumped directly on here at full current load, it's going to blow all of these Toshibas. We don't want that. You don't want that. I don't want that. Tooth Fairy doesn't want that. I don't know if I got enough time to get into this tonight. I'm trying to slip this in. It's now 1 o'clock in the morning. I just got done sitting up at the hospital with my my family member that's really sick. This whole situation kind of sucks. I think I'm gonna have to put this off till tomorrow evening and come back to it, but we're one step closer, one more video segment closer to being done. So on that note, we'll be back. I'm gonna call this the amp that's gotten me through a few more days up in the hospital. And I get to return back to this project this morning. It's Currently sick, so I had to go down to the hospital at 3:30 this morning. And I get to go back a little bit later today. I'm fine, by the way. It's not me. If I remember correctly, which I'm pretty sure I do, this amp was presenting as a hard short, and the hard short was up here on the circuit board. You see, we have this raised edge that comes through here. That bias circuit had been burned up before. This trace over here on the relay, over here, when it gave this, there was no bias anymore. Somebody has repaired this trace over here. So this had been shorting for a hot minute. Well, you see these slots in the edge of the board? If we look right about through here, is where the heatsink was resting. That's this edge here. The heatsink is resting right up against that little nub of wire. So that little nub, you can see where it was arcing. A little black discolorization is all we need. Come on, focus. Focus, you fuck. Come on. That little black arc tells us everything. The board was shifted over and shorted out against the heatsink. So then we start looking around. And we see little nubs like this hanging down. That's a leftover remnant of a resistor for the output combiner network. How that wasn't shorting out, I'll never know. Now we go down here and we look on the heatsink, and we'll see that there's little pieces of aluminum schmutz on everything. There's little pieces of solder all around the transistors. So, needless to say, this is where our problem came from. Now, what I have seen happen a few times, it's very rare, but I have seen happen, where we have a wire that rubs through. So our 12-volt circuit goes through our resistors. This is our load resistor, which makes contact down here on the heatsink. That's our load, not resistor, pardon me. Our load resistor makes load resistor go into our diode. Our diode represents our load, and then we piggyback that along underneath the board, and that's what presents the bias to each one of the input transformers. I've had this short, and I've had this wire, that wire, and I think that wire at some point or another, for a myriad of different reasons, short, rub through, wear out. Now, if you look at this thing head on, like if we had the ass off, you would see that there's a pretty significant gap. This ledge that's on the heatsink here is pretty significant. So usually when these short out or they have a problem here, there's no pressure on these. There's more than an adequate amount of gap for these wires. Because when there's been another issue, usually has to do with the bias choke, or it'll have 12 volts backfeed through the transistor when it pops open, and then we have a heating issue that takes place, or somebody in one situation, for some reason, don't know why, somebody else came along and they replaced this. This is Teflon wire, so this is high temp, silver plate, oxygen free strand cable. They put PCB or a PVC based wire as their jumper here, and it got soft. The wire migrated through the PVC, shorted out. But that's not what we're dealing with here. It's this right here. It was making contact. I feel very firmly about that idea. At some point or another, either the screws on the face of the amplifier got loosened. It's probably when they had the transistors out, because this thing's been repilled and it shifted just a little. That's all it took. All right, clean the board off. We're gonna put all new thermal compound down for everything. I'm gonna trim this back and we're gonna recenter this. We're gonna clean this up, and I want you guys to see the this brown spot here, right there. That's from heat. telling you, it shows all. Okay, so I shaved the heat sink edge back from about here to about here. The other thing is I lifted this resistor up just a tiny bit, and then I went back and I sanded everything to make sure it was smooth. Got all brand new thermal compound underneath our load diode here and our load diode there. So we're going to know right away, and how we're going to tell is we're going to look here. If this pops up to 0.6 to about 0.52, we know we've won. The other thing that we're going to see is this trace that's here, if it heats up. Now I did the repair on the trace here. This is the relay that controls our bias circuit, but I couldn't help but notice that the traces that are attached to this board are becoming unglued from the back side of the board. So I've added this reinforcement. This trace that runs down the edge of the cabinet hits this trace pad, okay? And this trace runs up, and this is what runs our transmit LED. This trace runs up the edge of the board and hooks over and goes to fire the relay leg. So I grabbed the top of the board, folded the piece of copper over, and brought it down to reinforce this. So now that's solid and it can't move. The barrels for the coax connectors are solid. I'm not a big fan of having solid wire go to these boards, but they've got to be there to help support the board. This thing is delicate. This amp has been broke a couple times. So today, with this amp, we're going to see these solid conductors that are coming off our SO239 connectors as a good thing. Now, we have not tuned the amp in any way, which we're going to do that later. We're not doing that now. The only thing that we're wanting to look at this moment is to make sure this isn't shorting this trace. And we're not burning this up. I repaired this trace over here in the corner. So in theory, we're good to go. Now what we're looking for here on the FLIR is that there's no heating on this trace, this one right here. Okay. We're good. We can see our two driver transistors heating up, and the short is now gone. Okay, now the fun part. I gotta turn on the spectrum analyzer, and we gotta retune here, 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 and here. Then when we're done, we got to come back and we got to make sure that our capacitance over here on our output section is spot on. Away we go. Okay. This is a 5-watt slug we're reading in Ford at the moment. 1,000-watt slug in average or bird, however you want to refer to it. RMS, whatever. 1,000-watt slug in 2X. So that's reading 2,000-watt scale. So let's go back down to 1X for the moment. So we're putting exactly 1 watt worth of carrier as our baseline. These amps were designed to take 1 watt worth of carrier. Maybe swing an 8 bird. We're seeing over here about 25, 30 watts. We're on 14 volts. 1, 2, 1, 2. All right, that's on AM. Turn this back reading forward and turn the amp on. We're in high. Easily over 1,000 watts. Go to 2X. About 12, 13, give or take. And then this meter here. About 400 bird, average, RMS, whatever you want to call it. Let's take the low, medium, and high knob. This is low. At about 800 watts, go to medium. Right up to around 1,000. Let's go to high. 1, 2. Okay. Here's our input tune. It's a 5-watt element that's sitting between the 2950 and the messenger. 1, 2, 1, 2. It's on high, medium. 1, 2, 1, 2, 1, 2. Hello. And now down to low. 1, 2, 1, 2. Now, that being said, let's go back down here. This amp is designed to make 800 watts. We haven't seen it yet. 800 here. Not here, by the way. Here. On sideband. Where this meter reads accurately. This meter measurement on AM doesn't mean shit. And they say so in the manual for the Bird meter. That's the reason why Bird had to develop a peak kit. Let's go to sideband. Alright, sideband delay is on. Same drive. We're looking at the middle scale. At 0 and 2. That was on low. So here, we'll do that again. Low. At 500. Middle. At 1, 2. 700 watts. And on high. At audio. We're seeing 900 and some change. Now look over here. At our peak numbers have not changed. So, needless to say, we're back to working where we're supposed to be at for this amp. At 1, 2, 1, 2. Now, back in the day, I would have changed a bunch of stuff in this amp and been like, look at me. I've made this thing make 1700, 1800 watts. We start running into core saturation and power distribution issues, and there's all kinds of stuff that goes along with that. And then the box becomes unclean. Starts producing a great deal of first, second, third, fourth order harmonics. I mean the first order principal, second, third harmonics. That's about as far as we can go. This thing is literally working perfectly at this point. We've had a bad transformer. We've had bad output tuning cabs. We've had shorted out bias. We've had all kinds of stuff. We did a power wire upgrade. We had melted balancing resistors. We had a bad output tuning capacitor. This little metal clad cap had gone on to be with Jesus. It let the smoke completely out. The magic smoke had left the building. Now we're fully functional. I love my job. I am going to call this the amp that got me through. We're still having all kinds of health issues. Things really haven't gotten any better on my side of the street as far as my family member that's struggling. But this has given me something to come home and tiddlywink around with when I've been able to bin home. I'm averaging 3 to 5 hours of sleep a night, and I'm doing everything I can to keep my family members propped up and supported. I thank God for these people here in Patreon that are here and help and support me right now. Put a several big posts up on Patreon about what we're going through, what's going on over here, why I'm having to step away from working out here on the workbench, and the support has come back unanimously. I've have literally like 100 plus of you guys that are checking in with me every day, and I thank you for your support. Now, before we can call this a complete win, I got to go do the power wires on the fan. We got to verify that the power plug jack for the fan here in the back is working, which I'm sure it is. So let's go do that, and then we can move on. Oh, and the other thing I wanted to point out is, yeah, the board has been shifted. If you look at the gap between the phenolic here, you'll see that the phenolic is scooted over all the way to the very edge of the heatsink. Now the screws that are holding the faceplate on, they're not stock. Somebody has replaced those for some other reason. Let's go up here. Let's take a look at our gap on the heatsink and the edge of the phenolic over on this side. You see how these screws are barely holding on? The shorting issue of this trace being burnt and us having this inner trace, the one that's slightly discolored, turned into a resistor has been going on for a minute. So I'm glad we were able to get that squared away for him and get the bias working, because if somebody wanted to use this on sideband, it wouldn't take too awful long. It would smoke all of these Toshiba transistors. So, all right, heatsink sticker And I think we're out of here. Well, this is the end of this story. I have spent an absurd amount of time. These are all my different wristbands that I've been given. And we're not done yet, but I'm still going to continue to call this the amp that got me through it. My customer, I want to say thank you for sending this up and being patient enough to let me work on this. To all of you guys out there in YouTube land, we are coming to the end of the situation that we're dealing with, but we're not there yet. We still got a funeral and a bunch of other stuff we got to do here shortly. And we're not dead yet. We're at the tail end of things, but be patient. There's more and more and more coming. I got a lot of work signed up. I wish I could have spent the last 16 days, 17 days now working on stuff here, but it was most important to me that I was able to spend the last 3 weeks with my dad while he's been able to talk and communicate with us. That was more important to me than this radio stuff. I will warn you, you guys out there, that if you call and give me a hard time about your project, I'm just going to return it at this point. My family needs to come first and will continue to come first, and calling and giving me any kind of hassle about it, I'm just going to return your equipment. We're done. I don't want to deal with you anymore. So, thank God, nobody out there has decided that they needed to act like that. Thank God most of you guys have lost a parent before and had to struggle through cancer, but and you understand what's going on over here. And I appreciate everybody being empathetic to the situation. So, as always, I want to give a shout out to Penna, XS, Siglant, McMahon, Bird, Coaxial Dynamics. Awesome thanks to all the people on Patreon. I appreciate everybody patiently waiting for me to help my family in this hour of need. I say thank you. I know I haven't been putting any content in Patreon. I haven't been putting any content up anywhere, and it's just because I've been dealing. So, on that note, I say, gentlemen, I appreciate every single one of you. Appreciate you tuning in and following along, and we will endeavor to continue. I'll see ya. Thanks, guys. Click, click.